Now let's talk about self-sovereign identity in a bit more detail. Um, the Comprehensive Guide on Self-Sovereign Identity. This is a very good book. If you're interested in the topic, then I do recommend it for you. The definition given in this book or guide is that self-sovereign identity is a decentralized identity layer, which we previously mentioned that the internet, framework lacks. So this is a decentralized identity layer that gives individuals and companies the ability to assert their own identity. So it's not only about the data, but the identity itself. And then ask for and receive credentials from companies, governments, and educational institutions. And of course, securely and privately share data. These are the requirements for a successful self-sovereign identity. And for the last part where it says, and securely and privately share data, here we can say that, okay, maybe we need blockchain to provide this security criterion needed for self-sovereign identity. Now, we can also identify specific elements of the system. We need a distributed ID, which is distributed because it's saved on different parties of the system, which is the miners of the blockchain. But at the same time, it's an ID, so it's unique. So every miner in the network should have the same exact ID, and every issuer or system element should have a unique ID that no one else can be identified by. The second element is having the verifiable credentials or verifiable data that you want to verify. Yeah, data that you need to verify. So we call it verifiable credentials because they are credentials that you save as part of database, including tuples, including private data, etc. But they are verifiable in a public context. So although they do include private data, they have to be able to be verifiable publicly by anyone without revealing the private data. And if we dig deep into this concept, then we see that there is also already some standards that were proposed by the World Wide Web Consortium, or what we abbreviate as W3C. And this standard is basically followed by most of the SSI application solutions around the world currently. And one of the main elements defined in this standard is the verifiable credentials. How can we say that this is verifiable? And how can we say that this is a credential? What types of data that can be revealed as public and what types should be private? And where should we save each type of data, right? And then thirdly, we do have the encryption, because without the encryption, we can't guarantee the security of the data transferred through the internet. So you need to select a proper encryption scheme, such as the elliptic curve or the different hashing algorithms that are theoretically and mathematically, formally, and experimentally proven secure against known attacks. Now, talking more in a bit more detail about the elements and framework of an SSI application, as we said, we can identify the issuer, the holder, and the verifier. And also, we do have the distributed ledger, where all the elements of the system can access and read from. The first step of the framework is when the issuer decides that it will start generating some data that needs to be verified globally, and then this issuer needs to have its own unique identity, and then it needs to have his identity publicly available and saved on the distributed ledger, which can be accessed by any system element. And then once it has its own identity, then this issuer needs to define. So this is what defines here means, that the issuer needs to define what types of data or verifiable data it needs to generate. Now, in this specific solution or specific case that we will be using as a case study for PriFoB specifically, is for the university accreditation and credential verification, which is the diplomas generated by the universities in general. So, assuming that we have an institution that needs to issue diplomas according to the courses that it teaches for its students, then it needs to have its own identity all over the world that cannot be used by other institutions, and also cannot be forged. Like the type of data cannot be forged. And then defining the types of credentials issued by this issuer is very important, because then you can have one template and then you can use this template to issue as many credentials as you need. And then once you have the definitions and you have the identity, then you can start issuing credentials, which is the second step. And then the holders or graduate students can actually request these credentials from you and save it on their own local database. And here, because the credentials, of course, will contain or consist of private data, then they need to be saved off-chain, and they need to be saved locally for the users or in the users' databases. Now, once a holder has its own identity, his own credential, then it can share this credential because it's verifiable with any system element that they trust, so that they can prove that they have graduated from this university. And then the holder itself doesn't need to verify that the stamp on the credential is valid, or it needs to be stamped from the Ministry of Foreign Affairs or whatever. It just logs in through its wallet, access the distributed ledger, and then privately and securely verify this credential was actually issued by the credential issuers that it claims. So we have a claim, which is the credential, and we have the holder, which is the graduate student, and then we have the verifier, which needs to verify the claim that the holder is claiming, right? Note in this context that the holder and the verifier, both, they don't actually need to have an identity on the distributed ledger, because the data is already there. They just need to access it, and then actually they can download the whole data saved on the distributed ledger because it's already publicly available, and then they can verify it locally on their own computers.